to Work It Wednesday. My name is Paula Houghton, and I'm the Director of Special Projects at Foundations, Inc. We're the organization that's responsible for the Beyond School Hours National Education Conference. And these Work It Wednesdays are just our way of bringing you a little bit of Beyond School Hours at home all summer long. And today we are joined by the amazing Mary Curry from Mango Math. Mary is an expert at making math fun and engaging and accessible for all learners, and we're so happy to have her. Registration is open now for Beyond School Hours. You can find out more about that or about our upcoming Work It Wednesdays by following the links I'll post in the chat. And you can also follow us on social media. And if you want to post during this webinar about things that you find particularly exciting, don't forget to tag us. And with all that, I won't waste any more of the precious time. Mary, please take it away.
Okay, great. Thank you for having me. So I'm Mary Curry, and I have been a teacher for 20 plus years, as we all marked off, and so we're all veterans here, which is great. I have been working specifically on math education for about 16 years. Prior to that, I taught special education as well as regular education. So I have worked with students for a very long time. And so we're going to talk about math and how to make math engaging and fun. In particular, we're going to work on how do we get kids to master those math facts so that they can succeed in math and succeed and go forward in mathematics. So I'm going to kind of show you some ways to do that. So I'm going to start sharing my screen here. Can you get it so that I can share it, Paula?
Sorry about that. You should be all set.
Okay, great. Let me get on here and share. Okay, so here is how to be a math multiplication and division champion. So the first, let me get this into a slideshow. Hang on. Is it already a slideshow? There we go. So the tipping point in mathematics actually is as early as third grade. Third grade is the tipping point. And what happens in third grade to cause this effect between having kids succeeding in math and not succeeding in math? And you can say it out loud or you can put it in the chat, but what do you think happens in third grade? Any guesses on what happens in third grade that we have
multiplication
as a tipping point in mathematics?
They must learn how to multiply and divide.
Yes. So multiplication is first emphasized in third grade. And oftentimes that emphasis comes with the rote memorization of it. And it's quick recall and getting kids to be quick with their math facts. And that gets them to be really anxious about mathematics. And it's kind of the first time that they really start to figure out if they're good or not good in mathematics. So third graders really is an important time for kids. So I get it here on my screen again. So third grade, majority of students have formed their opinion on how they do in math and how they feel about math. So we really need to get mathematics early on with students. And then by fifth grade, just a second, I got all these things popping up. Fifth grade, the majority of students have determined already what track they'll take. So we will know by fifth grade if they're going to be doing advanced mathematics or going a regular route, remedial route, or an advanced route by fifth grade. And what happens in fifth grade? What is one of the subjects in mathematics that comes about in fifth grade that we introduce students to? You can say it out loud or put it into chat.
Long division? No.
Long division, but something else. Because kids actually can do long division on calculators these days, so that's not necessarily the thing that stumps them. But it's actually fractions.
I was going to say
we get kids understanding fractions. And fractions are actually the stepping stone into algebra. We do a lot of fractions within algebra and division within algebra. So we really need to get kids focused on how to get factors and multiples and understanding the difference on that. Now I put up a little data point here. It said in 32 states, including the District of Columbia, they looked at how to improve third grade literacy. And they found that math not only predicted later success in math, it also was the greatest predictor on achievement in reading and reading skills. That kids who did better in mathematics did better in reading. And they found that across the board. So we want to make sure that we really put as much emphasis into mathematics as we do as in reading. So attitude is everything. Attitude is the most important thing on getting kids' attitude, but also our own attitude in check when we're working with kids. So in doing this, I want you to realize, and it's very important to realize, that nobody is expecting you to be an Einstein. We're not expecting you to have the answers and be able to think about numbers really quickly in your own heads. That's not the goal of being a good teacher. A good teacher is somebody who cheerleads the student on, gets them to be excited about mathematics, and encourages them to perform well. Because you know what, even if a cheerleader or somebody who's working with mathematics provides the student with possibly the wrong answer at that moment of time, they're still making connections and they're still starting to get that brain development on learning how to make connections in mathematics. So know that you don't have to have the right answers all the time, but cheerleading kids on and getting them excited about mathematics is very important. Now, as I said, math achievement is actually the best academic indicator of how students do academically. If they do better in mathematics, they do better not just in reading, but all other subject matters. But it's also the best indicator of financial success. So the better somebody does in mathematics and the higher level of mathematics they have, the better they do financially. So if we could get kids into getting into algebra, then into geometry, and then going up into algebra 2, trigonometry, pre-calc, all those types of mathematics, they are going to graduate with better success financially because they're going to understand numbers better. So when they make decisions about loans and about how to spend their money and how to go to the grocery store and budget their money and budget their time, they are better consumers that way because they know numbers better. So our minds change our bodies. So we know that we can think to ourselves that we're good at something and we can become better at something. But can our body change our minds? So one of the things is this little video that I love with this, if it's gonna. So once you hear somebody laughing, it's actually contagious and others start laughing. So know that your body image and how you approach something is how people will, that it changes their body, it changes their mood. So if you smile at somebody, it changes their body, it changes their mood. So if you're working with kids in mathematics, making it fun, having laughing opportunities, having joyful opportunities, smiling and positivity, they are going to become positive about that subject matter. So that's why it's really important to make mathematics fun, and trying to get kids off of worksheets and off of independently working on something and getting them into groups and collaborating and communicating and having a good time together is really going to change the way they perceive mathematics. So let me get off that. There we go. Oops. So I'm going to apply mathematics to sports because oftentimes the parents will say, oh, my child is going to be this great football player, softball player, especially among young kids. You often hear parents who are taking them to a lot of sporting events to get them better at a sport so that they can, you know, use it to get into college or whatever. But there's a lot about sports that we can apply to mathematics. So when we're teaching kids at a young age to be good at a sport, we take it and we try to make it changing and fun, and we do constant changing in how you practice. So good coaches will change up practice and have different ways that they're learning that same skill. They're going to start with low skills and they're going to build on that. So there's a lot of repetition on a lower level skill so that we can get up to a higher level skill. So if you're thinking of sports, so my daughter plays softball in college, and you're just starting with the basics of throwing, but then it gets into how exactly do you throw. I throw nothing like she throws because I haven't worked on that skill, but it develops that muscle memory. So when we're doing with mathematics, we want to do the same thing. Change up practice so that we're always working on a skill and getting it down, and then build that lower skill into higher skills. And then we want to have that teamship and that ownership, and through games and activities, they start to get that fun competition in there, but we want them to also have a team building. So we want kids working together as they're playing games so that they're learning to succeed together. And they've actually found a study with high school students in particular, that if their teachers included a math game within their daily lessons, and they had that as a continual math game. So let's say the first day one team wins, and then the next day they play it again to see who wins the next day, is that students will stay in school in order to not let their team down. So they'll stay in that math class in order to continually help their team out. So they have found that teachers that do that, those students are less likely to drop out or miss class. So gameplay is very important that way. So looking at brain development, brain forms pathways. In our brain, it's all these, neurons and pathways that help us develop our memory and become strategic thinkers. And strategies give brains something to lock onto. So when I work with kids, in particular kids who have learning difficulties or have not found success in mathematics, showing them strategies is very important, because they might not remember that 7 times 8 is 56, but they might remember a mnemonic that makes them remember that. Like I remembered 7 times 8 equals 56 because I thought of a dance step, 5, 6, 7, 8. So that was the mnemonic that I could draw on, that strategy I could draw on to memorize that math fact. And then we want repetition. So repetition gets us there, and we often just rely on worksheets for repetition, which is kind of, kids getting a worksheet compared to kids getting to play. I don't think there's any question. Kids are going to prefer wanting to play over having a worksheet. So in our brain forms pathways, and we can have these simple little, like this path that just shows a little deer trail through a park. And that's that's what we're trying to do to get kids to memorize their math facts. They just get this little faint little trail, because each math fact they have to memorize individually. But if we provide them with a strategy, that little pathway then becomes a really well-worn path that they can always rely on. So if you're thinking about that with kids' brain development, if I'm just showing them, you have to memorize each fact independently, you're just going to have faint little trails. But if I show them a strategy, that develops a much deeper trail and gets a much more formed path in their brains. So to be a math champion, we want kids to accept that mistakes are good. We want to, as adults, when we're working with kids, know that mistakes are actually a learning point. So we want to know that mistakes are good. And we want to understand that speed isn't important. So we want to kind of take the speed elements out of time tests and things like that, because I struggled with learning my math facts, and I'd have to, just like with my little mnemonic for memorizing 7 times 8, I actually had to think through that whole mnemonic in my head to come up with 56. And so that takes a bit of time to do that. And there's nothing wrong with that time. That time it's perfectly fine. But we tend to think that kids have to get these things down like this, and we put sheets in front of them and getting them to try to memorize, or we do computer games in which fish are dropping and they have to pick out fish, and it becomes this really fast paced thing that adds stress on to students. And so we want to kind of take that stress on and realize that speed is not important. And then we want to make math fun for students, and we want to use manipulatives. We take manipulatives away from kids so early on, and I think that's to a detriment of kids understanding mathematics, particularly when we're getting into getting kids to get fraction understanding down, getting them to really understand what it is that they're doing. So we want to make sure we keep manipulatives in with kids as long as possible. So let's get into learning math facts and getting some math fact fluency. Just a reminder again, speed isn't important. So I provide kids always when I'm doing multiplication with a grid, and I do it with addition and subtraction. I do it with multiplication and division because I want them to see what they know. Because once they realize what they know, then what they don't know becomes a lot fewer and it doesn't become as stressful. So I work on certain math facts and emphasize those to build up to other math facts. So first we start with 1 times a number. And we have to understand that 1 times a number is going to fill in this part of the grid. It's the easiest one for the kids to master. Just understanding that 1 times a number is really is just 1 row of information. So it's 1 row of some object. So it could be 1 row of 3 things. It could be 1 row of 5 things, beginning to understand that that's what mathematics multiplication is about. It's just 1 grouping of something. And then we can do 10 times a number. And that comes with its own patterns as well, 10, 20, 30, 40, and getting students to understand that pattern. And so they can master their 10 times a number. And so then that gets that section of it done. And so now we're going to get into the more difficult math facts. And we want to start with skip counting. So skip counting, you can do it on making count strips out of receipt paper. You can easily get those at any store. If you go to Staples or anything like that, they're going to have rolls of strip paper, and you can make counting strips for the students. And we can do it starting with one that's 1 to 30 that they can just write out by themselves. But then they can also add in there 2 times the multiples of 2s, the multiples of 10, the multiples of 5. So they start to look at skip counting and counting by a specific number in multiples. So they start to master these, and they start to see patterns within this as well. They start to realize that some numbers end in, like with 5s, every other number ends in 5. The others, they form a certain pattern between even and odd, or the first number being even or odd. So they start to see patterns in it. And then we can get into skip counting 2 times the number. So if they've mastered their doubles in addition and addition, they can easily do their 2 times the number. And so they can get that mastered quite easily. Then we get into 5s. And one of the easiest ways to kind of do 5s is get kids to understand even and odd numbers. So if 5 is multiplied by an even number, it's going to end in a 0. If 5 is multiplied by an odd number, it's going to end in a 5. And you can make a simple little grid like this. The student can make it themselves, and they can use a deck of cards or a dice to generate a random number. And they're just going to multiply that number times 5 and just cover it up on the board. And so they're just trying to get a row of numbers covered, or the whole board covered. So they're just really working. It's not so much the game aspect of covering things, but kids like to cover something up, so it makes them feel like they are accomplishing something. So they really can just do this, doing it with a card or a dice. They can do 6 times 5 would be 30, and they cover that up. So it's just a simple way that kids could do this at home. They could do it with their parents. They could do it with a teacher virtually, by just having a simple board like this with multiples of 5 on it. So it's a very simple game. So then they start to master their 5s. So now, as you can see, we're starting to really fill up that grid on those facts that they are going to know and master. Then the next one I go into is doubles, 4s, which is double double. So one of the things with 4s, they have to, if they're thinking of a number, so let's say I think of 4 times 6, it's actually the same as 2 times 6 plus 2 times 6. And you can talk about how 2 times 2 is 4, so that they get that understanding of it. So if I think double double, I'm really thinking 4 times 6 is 6 doubled and then doubled again. So I think of 12 plus 12, which is 24. So if I look at 6, I double it, it's 12. If I double 12, I got 24. Same with if I do 6 or 4 times 7. I'm going to think the same as 2 times 7 plus 2 times 7. So I'm going to double the 7s. So I double 7 is 14. I double 14, I get 28. Gets a little trickier when I do it times 9, or if I do it times 8, because I'm going to have to carry a number. So it's the same as 2 times 9 plus 2 times 9. which is going to get me 18 plus 18. As I said, they're going to have to think of 8 plus 8 is 16 and carry that 1 to get the 36. But it is a strategy that they can use. And we have other strategies on the 9s, so they can use 2 different strategies when they're working with this one. But it gives them a strategy to work on. So when they see something times 4, they're going to think double, double. So then we've got our 4s mastered, and we can work on a game that kind of gets them to master their 4s. And you can do it simply with just a grid paper, and you can take dice or cards, playing cards. I do a lot with playing cards because playing cards have every number in it, 1 through 9. If you want to add a 0, you can just take the jack and write a big 0 on a jack. And so then you actually have 0, 1 through 9. So you have every digit. But the cards have them also have each number 4 times within the deck. So they're just a great tool to help kids work on their math facts. So you can do 4 times, let's say 4 times 6. And I just need to make a grid on the board that's 4 times 6, which covers 24 squares. So kids can then draw another one, 4 times 8, or 4 times 7, excuse me, is 28. So they're just going to make a grid that's that. And the object of this game, if you've ever played the game Blockus, which was one of my kids' favorite games to play, you're just kind of covering up spaces on a grid until somebody doesn't have a space to fill in. So you're just going to keep going back and forth. 2 players can play this, filling up space on the grid. So I have 4 times 2 gives me 8. I'm just going to put that on the grid. And then I have 4 times 4 is 16, and I can put that anywhere on the grid. And then I've got 4 times 9. And so now I have to figure out, do I have a space on this board that I can make a rectangular array that is 4 times 9 or 36. So you can see that that's kind of impossible within our space here. So then they can actually talk about, can I break 36 down into maybe 6 times 6? Or is there other ways I can break it down to fill in the space? So they're starting to look at ways that they can break down a number so that it equals the same amount. So it's a great way to get kids to kind of practice their math facts and start to realize that multiplication is rows and columns, groupings, and it gets them to understand area. There's lots of things that this game gets kids to think about. And so it's a great tool to use with kids when you're practicing math facts. So then we go on to 3s. And I have studied lots of songs to master 3s. And this is by far the best one out there for mastering numbers. And one of the things, this is an old one. I grew up with this, Schoolhouse Rock. Some of you, I might be dating myself a lot, but this was the commercials that came on between every cartoon when I grew up. And this one with 3s is really the best one because it does the numbers in multiples of 3 as you go increasing order as well as decreasing order, and they're repeated a couple of times. So I'm going to play this one for you.
6, 9, 12, 15, 18, 21, 24, 27, 30, 6, 9, 12, 15, 18, 21, 24, 27. That was from 3 times 7. 3 times 10 is 30. 3 times 9 is 27. 3 times 8 is 24. 3 times 7 is 21. 3 times 6 is 18. 3 times 5 is 15. 3 times 4 is 12. 3 times 3 is 9. 3 times 2 is 6. And 3 times 1 is 3, of course. I think the pattern was 4. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now multiply 10 backwards. 3 times 10 is 30. 3 times 9 is 27. 3 times 8 is 24. 3 times 7 is 21. 3 times 6 is 18. 3 times 5 is 15. 3 times 4 is 12. And 3 times 3 is 9. 3 times 2 is 6. And 3 times 1. What is it? 3.
Okay, I'm going to stop it there. But one of the things that I love about this song is when I said the repetition of it, but also with regards to memory, you're able to memorize groups of 3 better than you're able to memorize. So that's why you get phone numbers in groups of 3s or 4s, social security numbers, all that are in groups like that. And so it adds that extra memory component to this. So it's a really good song. And then there's I'd have to, personally, I think there's very few really good songs out there and to memorize your multiplication facts, but this is just one that really, I think, is outstanding. Oops, let me go on from there. So then that gets the kids mastering their 3s. So as you can see, our board is starting to get filled in. And so we're starting to kids to start to learn that they're mastering their math facts. Now, I just want to stress that, you know, we're going through this really fast, but with kids, you'd spend a good week or some kids might need a little bit longer than a week, but you're just working on that one math fact at a time so that they're getting mastery of it. So then we go into 9s, and I love 9s. 9 are my favorite. They are so cool. It's just such a neat number. So with 9s, there's all these patterns within 9s, which kind of make kids understand how interesting mathematics is because there's all these patterns within 9. So if I look at my 9s and I just multiply them across, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72, 9 times 9 is 81, and then 9 times 10 is 90. So you might see right away on the listing of all those that the numbers in the tens place will increase in consecutive order. And then you might notice that the numbers in the ones place actually decrease in consecutive order. My arrow's going the wrong way there, but they decrease in consecutive order. So that's something that's kind of interesting about 9s. And then if I draw a line between the midpoint of all those, is you'll see that they are mirror images of each other. So 9 times 5 is 45, while 9 times 6 is 54. 9 times 4 is 36, while 9 times 7 is 63. 9 times 3 is 27, 9 times 7 is 72. So there's that patterning with them, which is really kind of cool. Now, if I take it and I add all those numbers together, you'll see that all the factors of 9 actually add up to 9. So 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9. So that's kind of cool about it. You might also realize that if I do 9 times 2, the number in the tens place is 1 less than the number I'm multiplying 9 times. So 9 times 3 is 27. That first digit is 1 less than 3. 9 times 4, that number, that digit is 1 less than 4, which is 3. 9 times 5, that digit is 1 less than the 5s. So that gives them a pattern. Also, so sometimes I'll tell kids when you're multiplying 9 times 5, think of the one number less than it, and then what number plus that equals 9. So it's a little bit of a strategy they can use. I know some people use the finger strategy, which is if I put up 10 fingers and I'm doing 9 times 7, I take down my 7th finger, wherever it is. So then I have whatever's, anyway, I didn't think this one through and I'm doing it backwards on you guys. So you can do it that way, the finger one, and that works out to be 9 as well. So there's that strategy that you could work with kids. And so so they get to see the patterning and they start to master the facts because that has some really cool patterning to it. Then one of the things that they can realize with 9s too, is I was saying any number that is a multiple of 9 actually adds up to 9. So if I was trying to figure out if 9 is a divisor of 3,501, if I added up those numbers and I get 9, then it is a divisor. So 9 can divide evenly into 3,501. If I have 24,381, if I add up all those digits and I get 18 and then I add the 18, I get 9. That 9 divides evenly into that number. So they start to learn that there's all these things within 9 that I can quickly figure out what 9 divides into evenly. So there's really a lot of quick, cool strategies on 9. So I get kids to think about these and then we get them to master those 9 facts. So then we get those 9s mastered, and all we have left now is 6 times 6, 6 times 7, 6 times 8, 7 times 7, 7 times 8, and 8 times 8. So we're just left with those 6 facts that we need kids to master. And you can do different, oops, sorry, my dog's barking, different strategies on that one. And one, I'm going to use fingers as calculators. So our fingers, I did it with the addition one, if you saw that one. Just a second, I'm hoping somebody will get my dog quiet. Is that I like kids using their fingers as calculators, but not as counters. I don't want them going 1, 2, 3, 4, 5. I want them to use them as a calculating tool. So you can do that with 8 times 7. So I get the kids to think 8 in your head, but put up 7 fingers. And I'm going to show that in a diagram. So they're going to have 7 fingers up. They're going to think 8, put up 7 fingers. So then they just have to think of 5 times 8 is 40. 2 times 8 is 16. So 8 times 7 is 56. I just have to add that 40 and the 16. So they're using their hands as calculators. I said before, as I do a mnemonic. 8 times 7 is 56, because I have been taught when I was a little girl, think of dance steps 5, 6, 7, 8. And that was what I used to master it. But you can use this finger counting as well. So another example of it is 6 times 8. I'm going to think 8 in my head, and I'm going to put up 6 fingers. And then I'm going to think 8 times 5 is 40. 8 times 1 is 8. So 8 times 6 is 48. So they start to learn that they can use these fingers as a calculator, because they would have mastered their 5s times a number. So another example is 7 times 6. I think 6, and I want them to think the even number, because 5 times an odd number is going to give them that last digit being 5, so it's not as easy to add up. So they're going to think of the even numbers. So they're going to think 6 in their head, put up 7 fingers. 6 times 5 is 30. 6 times 2 is 12. So 6 times 7 is going to be 42. So that's just a strategy that you can work with kids and getting them to memorize those last few math facts that they can't get memorized. So now we want to get into some games. I'm going to show you some great games. And some of the reasons for games is that games help you start to make connections between mathematical concepts. It also helps you with quicker recall. The faster you play, when you're playing a game, you start to recall numbers faster. You use some mental math. It helps take things from short-term memory into long-term memory. So we want to be able to get kids through games to put things into long-term memory. So anything that's joyous or sad, it tends to go into your long-term memory better than just mundane, normal things. That's why I can't remember what I ate yesterday for lunch, but I can remember, a nice meal I had with my husband, for our anniversary, because things that are joyful and happy occasions tend to make you put it into long-term memory. So, and all that stuff builds confidence. So we want to build confidence in kids. So the first game was, if you did the addition one with me, it's the same game, but we're going to do it with multiplication. So it's called Salute. And I'm going to just stop and see if there's any questions, because I see that popping up on my screen. Is there anybody that has any questions prior to me getting into games? Any questions before I get into some of the games? Make sure you can also unmute yourself and just ask as well. So the first game I'm going to show is Salute. It takes 2 people to play, and I haven't quite figured out how to do this virtually. So I apologize. I know a lot of you are virtual, but it's a great game once you get kids back together and in person. And it's something that you can teach the kids to do at home with their siblings or with their parents. All they need is a deck of cards. So it takes 2 cards. The dealer deals out 2 cards face down so that the children cannot see what cards they're going to have. So the dealer takes those 2 cards face down and gives them to each child. And each child, when the dealer says salute, is going to take that card and put it on their forehead. So they've each got a card on their forehead. Now they can only see what's on the other person's forehead. They don't know what's on their own forehead. So when the dealer, when the kids have those on their foreheads, the dealer is then going to tell them what those two numbers multiplied equal. So they're going to say the product of those two numbers. So 6 times 2 is going to be 12. So the dealer will say 12. And now the children have to figure out what card is on their head. So as soon as they see the other person's card, they're going to think to themselves, okay, I see a 6, so what's on my head? And know that when you first play this game with kids, they're just going to shout out what the card they see on the other kid's head. It's just normal. They see a number, they're going to yell out the number and not think about what's on their head. It happens every time. The kids laugh about it and then they go on. And what's nice is a deck of cards has 52 cards in it. So you're going to get through a lot of practice with it. So they've got to figure out what's on their heads. And the first person who says it then gets the cards. So you know who has won that round by they get all the cards. So at the end, the person with the most cards wins. And then they become the dealer. So it becomes those kids that need the practice, get the practice, and the child that gets into a nice rotation of the kids. So once again, you deal it upside down, they put it on their foreheads. The dealer tells you what the two multiply out to be, 28, and then they have to figure out what's on their head. Sometimes the child won't respond, and that's fine, but you want to start matching up kids who are at the same level. So some kids have their math facts down better than others, so you want those kids together in a grouping. Otherwise, you get a child that feels defeated and won't continue on, so you want to make sure you kind of start grouping these kids up quickly. So what actually is happening, I'm going to go back a screen here for a second. Oops. Is when the kids are playing this game, the only person who's doing the multiplication is the dealer. The two kids who are playing are actually trying to figure out what's on their head or doing division. So I always tell kids that this is a multiplication game, but actually the two players are doing division every time. But if I told them it was a division game, they would not play it. So never say you're practicing division, always say you're practicing their multiplication. But once they get really good at it, you can then bring up the fact that, yeah, you're actually working on your division facts. So this is one of those sneaky games you get in there to get kids to work on their division facts. So that's why I have it, this little thing that they're actually working on division. So one of the things you should know when you're playing games is the first time that a child plays a game, you're actually just trying to learn the rules. And so this means any type of game out there. So if you're playing checkers with a child, or you're playing a card game with a child, or you're playing one of these math games with a child, the first time that you're playing it, they're just trying to figure out the rules. The second time, they're still working through those rules. It's not until about the third time a child plays the game that they're starting to apply some strategies to it. So just know that when you're playing games with kids, oftentimes you think, oh, I played that already, I'm done with it. You don't want to just discard them, because you want to come back to them, because they're going to start to learn strategies, and it really gets into good problem solving skills that they really need to learn to develop. So make sure you play games multiple times with kids. So this first game I'm going to teach you is a factor game. Now, one of the things we said early on is by 5th grade, students start to determine their track in mathematics. And a lot of that has to do with them having difficulties in fractions. And one of the things that with fractions that cause difficulty is trying to get fractions down into simplistic forms. And that's where you have to have kids understanding their factors and their multiples. So we really want a lot of practice in kids doing factors and multiples. So this factor game is a great one to get kids working on those. So it's just a simple board. I just have the numbers 1 through 49 on it. And the first player goes, and they can pick any number on the board that they're going to cover up. And they're going to, let's say they pick 28. So they're going to give themselves a score of 28. Now the yellow team, or the other player, comes and gets to cover all the factors that make 28. So they're going to cover up they can cover up 2 and 14, 4 and 7. So they get to cover up any of the two numbers that multiplied together make 28. And it's just going to be the two numbers multiplied together to make 28. And so then they get to take those numbers, 2, 14, 4, and 7, and add those together, and they get a score of 27. So when they add those all up together, they get 27 points. So red team picking out 28 won them, or they're ahead now by 1 point. So now the yellow team gets to pick a number, and let's say they pick the number 25. Or no, sorry. Yeah, the yellow team goes and they pick the number 25. So they get 25, and then the red team has to cover up any factors of 25, and all there is on the board is the number 5. So they only get 5 points. So meanwhile, the yellow team gets 25 points, the red team only gets 5 points. So as I was saying, that once they practice this, they start to learn strategies, and they start to look at numbers that are more prime numbers, or numbers that don't have as many factors. So if I had picked 24, the other player would obviously have a lot of numbers that they can cover up. So it gets them to start to understand numbers a little bit deeper. So it's a great game to play with kids. And if I pick 16, then I could actually cover up. If you see, I've already got the 2 covered up, and so they would only have the 8 that can be covered, because the 2 was already covered. So you start to see more strategies in there, because some numbers have been covered up, so it's more difficult to find factors that they can cover. So that was one game. This other game is kind of the same idea, called Tic Tac Toe. So in this one, once again, the more they play it, the better strategies they start to learn. Is you have a number line at the bottom, 1 through 9, and then the numbers above. You notice that I don't have every number up here. I have 1 through 10, but I don't have 11. I don't have 13. That's because I don't have numbers down here that will multiply together to make those numbers. So I'm just using the multiples of these numbers up on the board. So the first player gets a little bit of strategic help, because they can put 2 counters on any of the 2 numbers on the bottom row. And so they're going to take those 2 numbers and 2 times 6 and multiply those together, and then cover up the 12 on the board. And you're going to have one player be yellow and one player be red, or however they want to change their colors up. They're going to have 2 different colors. And the object of the game is to get 4 counters in a row, either horizontally, diagonally, or vertically. So the first player has multiplied the 2 times the 6, and they're covering up the 12. Now the second player, the trick here is only can move 1 of the 2 counters on that bottom row of 1 through 9. So they have to think to themselves, what are the multiples of 6, or what are the multiples of 2, and what number I can cover. So in this case, they're going to move just that 1 on the 2 over to the 8, multiply the 6 times the 8, and cover up that 48. So this one has a lot of great thoughts and strategies to it. So they now have that one covered. Now the next player, the yellow player, can only move 1 of those 2 counters, either the 6 or the 8. So they have to think to themselves, looking at their board, what numbers do I want to cover that are going to be in my row, horizontally, vertically, or diagonally? So now they're looking at, I can look at the 8, the 9, the 10, the 14, or anything around that 12. So they're going to have to start thinking about what they're going to cover. So they're going to move that that counter on the 8 over to the 1, so they can cover up that 6. So they're starting to make their row. And know when the kids first start playing this, they really stick with the numbers that they have mastered, and they tend to stick to the numbers up on top. So know that as they practice this, they get better with their math facts. So now it's the red player's turn. They've got 1 on the, they can use the 1 or the 6 to cover up something. So we're sticking with that 6, I think. And we're going to do 6 times 7 and they're going to cover up the 24 so that they can keep working on that row. So they're going to go back and forth playing this game. The next player is actually going to move the counter on the 6 over to the 4 and multiply 4 times 7 and cover that 28. So they're working on their 4 in a row. And as the kids practice this, they start to get better at strategy. They start to get better with their math facts. There's so much thinking in this game. So it's really a good one to do with kids. So the next player's got a 4 and's got one on the 7. So if you can guess, that player is actually going to move the one on the 7 over to the 5, and they got 4 times 5. And so strategically, they just blocked the other player. They moved it onto the 20. So now that player cannot do that, work on that row of 4 anymore. So know that that doesn't happen right away when playing this, but definitely when you get 4th and 5th graders who start to get their math facts mastered, they can start to cover up and be more strategic with their play. Like I said before, this is really good with kids, starting them to understand their multiples and their factors of numbers. It gets them really processing numbers in a great way so that when they get into fractions, they start to understand how they can break down those fractions better. So now I'm going to show you some strategies on working with kids with multiplication. So one of the things, and I hear this a lot, is that multiplication isn't the same today as it was when we grew up. We just did the algorithm and kids, just processed it, and they were able to do it because they followed this strategy and they followed this process. And that's what I did. And I have learning disabilities. I'm dyslexic, and so I could follow a pattern, but I had no idea what I was doing. So I never got a real concept of how numbers work together. And so I couldn't then use that understanding of numbers to go further in mathematics because I just was not grounded in how numbers work together. So with this number 3,204 or 3,324, I can break that down into its multiples, or break it down into its place value. So I have 300, I have 20, and I have 4 times 6. And now if I multiply that 6 times each one of those top numbers, I've got 24. 6 times 20 is 120. 6 times 300 is 1,800. So I can get kids to break this down, and so they get an idea of what actually is happening when they're multiplying the numbers in that algorithm that we normally have done. And then all I have to do is add those numbers up. I can get them into a column, and I add them up. I got 1,944, which is the exact answer of 3,024 times 6. So it's a strategy kids can use to just break down that number into more workable parts. And so for me, when I work with special ed kids, they always forget which number they're carrying, where that number goes, what they're supposed to do with it, things along those lines. So I break it down for them in this fashion. I can then do this with double-digit numbers times a triple digit. So I can have the kids take an estimate of what they think that answer would be so that they start to get an idea of what answers round should become. So you can have kids estimate, but then you can have them multiply this out in their place value. So 324 times 36 is 30 plus 6. And then do that same multiplication along the way. So I get 120, 600, and then 9,000. And then the 6 times each of those numbers is 24. Then 6 times 20 is 120, and 6 times 3 is 1,800. And then I just add up each one of those columns, and I get totals of those columns, and then I take those over, and then I add all those numbers up, and I get 11,664. So it gets them to this answer. And I really, as a special ed teacher, working with kids who have struggled with this, this is a great way to do it with them. I do have teachers that have come to me and said, that's just too much adding. They shouldn't be doing that much adding, but it gets them to the right answer. So I'm not sure the concept that they are actually doing multiplication. It's just in a different form than what we were taught, but it gets them to the right answer. And you can do the same thing with division. So just like, I'm going to go back to this one again. So what happens with this one too is you can get it to get kids to break down to understand what that number is that they're carrying. So you can break this down with kids so that they understand when they go back to the original algorithm that we all used, they can see what numbers are being carried and why they're being carried. So if you're going to transition from this format to the normal algorithm, you can go through those steps with the kids so that they understand it. Now going on, oops, sorry, I'm going backwards again. You can do the same thing with division. So I can use the same strategy with kids with division. I'm going to divide 4 into 452. I'm going to break those down into their place value. And so I do 4 into 400 is 100. And I can break down the 50 into a workable number, 40 plus 10. And I know that 4 into 40 is 10. And so then I have this 10 over here that I can move over to the ones place, which gives me a 12. And I know 4 goes into 12 3 times. So it breaks that down. So I now have the answer of 452 divided by 4 equals 113. So it gives them a strategy on how to do multiple division. And then I can get into double digit division with kids with this same strategy. I'm going to keep the break down that 450 into its place value. I'm going to keep the 14 though, and I'm going to break that 300 into a 28, which they can understand is a multiple of 14. It's just doubled 14. So they can see that 2 goes into that number, and then they can move that 20 over to the 50. That gives them 70. They can work out 70 if they do, and they start adding 14 up, 14 up, 14 up, and start to get closer that way. So it brings it into the same concept as multiplication for them, as multiples of a number, and they can see that that's 5. And then they can see that that 350 divided by 14 is 25. So I see that this has more steps to it, and it takes a lot more thought process, but it helps kids understand what they're doing with regards to long division using that same strategy. So that's a lot of information there on this. We do a lot of math problems and stuff on our social media. If you have any questions about what I just showed you, please ask. I'm going to put up the URL of handouts that go along with those multiplication games that I showed you. So I know I've just presented a lot of information really quick and not a lot of engagement. So now I would like, if you have any questions, I'm happy to answer them. I'm going to leave this up here for a little bit so that you can write down that URL that you can go to and get that Tic Tac Toe game as well as the factor game. And I think I have the multiples of 5 on there. I can't remember what else I had on there, but I had some games on there that you can get. Oh, I see that they put it up in the chat box, so you can just copy it there. So thank you. You can get a reach of me if you have any questions about Mango Math, or you have any questions about how to work with kids in mathematics. I'm happy to answer them. My number on there kind of got messed up, but it's 833-233, and then it's math, M-A-T-H. I think it's 6284. So you can call me or you can email me. I'm reachable, so I can happily answer anything you have questions when working with kids or what Mango Math is about. So if you have any questions, and I see that there's a poll put up.
Thank you, Mary. This was so great. We have some more webinars coming up, including another one from Mary on problem solving in 2 weeks. So please be sure to check out our registration page. I just posted the link in the chat, and join us again. Next week, we have a webinar on fun and healthy back to school activities. for social and as well as physical health. And if anyone has any questions for Mary, I'm sure she would be happy to take those now. Let's see. It looks like there's been a shift in how do you feel about math. We got
Good.
I love maths. A lot of people excited to get their students excited, and some people willing to at least pretend that they're excited for them.
Good.
Thank you so much, Mary, for helping
You're welcome.
on that. We're have you, and thanks for all those really fun ideas. And we'll see you. We'll see hopefully all the attendees next week, and we'll see you in 2 weeks.
Okay, great. Thank you so much.
Thank you.